Okay, this video is about something called specific heat. The way I like to introduce specific heat to my students is talking about the swimming pool in the summer. So everybody enjoys being in the water, right? It's a nice temperature, nice to escape on a hot day. When the concrete or travertine or whatever that material is on the ground is not wet, it really hurts to walk on that after it's been baking in the sun for a while. Same with the metal poles that you can use like on the ladder to get out of the pool. When those aren't wet, they actually really hurt when the sun has been beating down on them. And something that's related to specific heat when talking about the swimming pool is that water has a higher specific heat than that concrete does. Okay? And basically what specific heat is saying is it's saying how much heat is required to raise the temp of 1 gram of a substance by 1 degree Celsius. Again, this is not a very beautiful definition because it's just me saying out loud. Your notes probably have a better, more succinct definition, but basically the idea of specific heat is, hey, how much effort, essentially, how much heat do we have to put in here to make this specific substance raise its temperature? And so water, it actually takes a lot of heat, a lot of energy to raise its temperature, which is why we swim in pools of water and not pools of metal, because it doesn't take that much heat to raise the temperature of metal. And so different substances have different specific heats. And we can actually calculate how much heat needs to be absorbed or released or whatever to raise the temperature for a specific sample of a substance using an equation that we know. And this equation is Q equals M times C times delta T. So Q stands for heat, and we usually talk about heat in terms of joules. And so that's really just a big J. M, you guys are great at, it's mass. We look at it in grams. C, that is our specific heat. There is a specific number for every different substance. And so the units for this is joules per grams degrees Celsius. And then finally, delta T, delta means change, so it's the change in temp. And in this unit, I'm probably just going to be using degrees Celsius as far as I remember for the whole unit. So you could be given a problem where they tell you, okay, we have a sample of water. There's 100 grams of it. And we want to know how much heat it takes to change the temperature by 15 degrees Celsius. So we know that our delta T is 15 degrees Celsius, our mass is 100 grams, and then we are given water. The specific heat of just plain water is 4.18 joules per grams degrees Celsius, so that's our C. So we have everything here, right? We have M, we have C, we have delta T, but we do not have Q, and they're asking for how much heat. And so all we're going to do, it's pretty simple. We're just going to plug this stuff in to see what the answer is. So we're going to say 100 grams for our mass times our C, which is 4.18, because we're talking about water, times our change in temperature, that's going to be 15 degrees Celsius. And so I'm going to take my calculator, I'm going to say 100 times 4.18 times 15. And I end up getting 6,270 joules are required to heat up 100 grams of water by 15 degrees Celsius. So really what specific heat is, when we're doing these equations, just figure out who goes with which variable. Please pay attention to who we're talking about because your specific heat changes for different substances. And then make sure you're in the right units.